So this is what I have so far for a project. This is like a 110cc Chinese quad bike that a friend of mine had given me. That the suspension is with it, the wheels and the axles are with it, the tires are flat, the body's missing. What you see here is part of it chopped apart already. I've been working on this thing for a couple of weeks, mostly just taking it down to just kind of making a plan. So I needed to kind of figure out how good a shape it was in, what all the stuff it had, and then from there I'm going to, I want to make a plan as to how I'm going to go forward. So, like I said in my introduction, one of my hobbies is to control electric motors with computers, and not so much just computers, but speed controllers, having some sort of computer input to a speed controller, autonomous stuff, autonomous drones. You guys probably are aware with DJI and also all the RepRap, automatic piloting drones. That's been a hobby of mine as well, but the rules are changing and that kind of stuff, and it's kind of a bigger deal, that is. But this is another form of the autonomy for me is using them to control a vehicle. I have a small rover that I've been working on, a little track device that we built. Actually built the body of it at the school, and I've made it autonomous, and we'll probably show you that in one of these videos. But this is the project that I want to kind of introduce you to. This is what this mostly is a way to use this motor. I've had this motor around here for a long time. This is it's kind of an older technology motor. It was originally made by Briggs & Stratton, but now it's kind of a knockoff of that. But this is a pretty powerful motor, and I've had it around for 4 or 5 years. We had it in the vehicle at the school, and we kind of figured out what it would do, but it wasn't the right application. So I want to find out whether this motor will run a vehicle kind of this big. Originally, this was supposed to be big enough to ride in, kind of a person, an electric go-kart, if you will. But since then, I've decided that this has more value to me as a learning tool. I want to learn about autonomy, and I want to learn about the sensors. I want to learn about how to make a vehicle travel through space on its own. So to do that, of course, this vehicle has to have electric steering, and of course it's going to have electric drive just because it's that much easier. So this motor is going to get mounted into this frame. I'm not sure exactly how yet. I have some ideas. One of the ideas I have is to mount the motor on a pivot. So it pivots up when it's driving, and then when you want to slow down and need to apply the brakes, remote control, just the act of slowing down torques the motor the other way and applies a master cylinder or something. I don't know. Just an idea I've been kind of banging around. But so I have this motor, and everything I know about it, it's around 4 or 5 horsepower, about 5,000 watts in perfect situation. It's a little bit banged up. I'm thinking it's probably going to give me around 4,000 watts, 4, 5, 6 horsepower. I'm not sure. It's a torquey thing, though. It'll give me lots of torque, I would imagine. So to run that, you need this technology. This is where the computer part comes in. This is a speed controller that takes input from a battery, does some math on the electricity that goes through it, and sends a modified signal to the motor to control its speed and direction. So this is a really good quality speed controller. It's out of previous projects. This will handle all the torque and RPM that motor needs. And this also has computer inputs to it. So if we wanted to, we could have this be run by some sort of drone autopilot. We could have it run by a Raspberry Pi or an Arduino. We could use GPS on this thing. We'll for now we have to build a rolling chassis, but this speed controller will allow for that kind of connection. So I've had the motor and the speed controller for a while, but what I didn't have is a decent set of batteries. So I splurged this time, and I bought 4 of these motorcycle-sized batteries. And anybody who's into bikes, this is your typical size, 6 by 7 by 3.5 or something. But the difference in this one is it's lithium ion. And I bought 4 of these batteries to match the powertrain of the speed controller and the motor. So these 3 things here I can kind of bring to different vehicles as a kind of a package, right? So so this is kind of a, I'm not sure how long it's going to run. I think this is like 30 amp hours or something. So I don't know how many amps it's going to draw, all this stuff. And that's another reason I want to build this thing. I want to understand the electricity of that. How much current does it take to move a 200 or 300 pound vehicle around? Nice thing about these batteries is they're super light. All right, so we're going to save a lot of weight on this vehicle, but it's still a steel vehicle with lots of steel in it. The tires are heavy. It's going to weigh a couple hundred pounds probably by the time we're done. But of course, if it's going to be remote control or autonomous or anything, we have to have the steering operated by some sort of motor. I'm just going to move the camera up here. So here I have different possibilities of that. Again, stuff I've acquired over the years. This is this kind of a medical grade electric motor designed for medical machinery with planetary gear sets. And as you guys get into powertrains, you'll understand the benefit of a planetary gear set. This gearing right here gives me 137 to 1 from that motor. So every 137 times the motor spins, this shaft spins once. So this is a very slow moving shaft at 12 or 24 volts. So maybe I can put a lever on here to move the steering, or put this directly in place where the steering wheel used to go, or take this whole shaft out. I don't know, something like that. One of the other options I have is again a DC motor with a spur gear box on it. So there's some gears in here that change the speed of the motor out to this hex shaft, and this could mount, cut this off, mount that, move it down. Not exactly sure, put its own lever on it or something. So that's an option too. But the problem with these two motors is there's no way to measure the position. And any autonomous vehicle, the computer needs to know which way it's steering. It needs to know always which way the wheels are pointing. So if we're going to use either of these motors, we'd have to put in some sort of device that measures the direction of it. This is called an encoder. It's a digital counter. It measures, using little, I don't know if you can see it, but it measures the position of these slots as it goes around, sends it back to a computer, and the computer can keep track of the position of that steering, so it knows what to do with it. So to use these motors, I would need this. Here's another way of doing this. I've acquired this. This is a 10 to 1 gearbox, but I also have a 100 to 1 gearbox, and I could run it with a stepper motor. I could mount the stepper motor in here. The thing about a stepper motor is it's very accurate to position things. So if I could make this drive a lever that comes out of here, right? We could use a computer running a stepper motor to decide where the steering is. So that's another option. And a fourth option we have is just a linear actuator. The nice thing about this one is it does have some wires in here that has a position sensor. So the computer would know how far out this is. And maybe this thing just moves the steering back and forth. The problem being this doesn't move very quickly. The steering would be very kind of slow and sluggish on this. So not the best option. You can get faster ones of these, but I have so many options that I think I can just, omit this one fairly early. So that's what I have. That's what I'm doing. I'm going to be every time I kind of make solve a different problem, and there's going to be lots of problems to solve, I'm going to make a video. I'll post these videos to eCentennial. I want to start a bit of a blog or kind of an ongoing project, and you guys can offer suggestions and ask questions, and I'll show you how to do different processes. I'll show you how to, I'll try to show you different skills that you're going to need in your career as a heavy equipment mechanic or truck mechanic or whatever it is you found yourself doing. I happen to enjoy the fabricating and the problem solving part of learning to be a heavy equipment mechanic. So these projects for me are very, I really enjoy this stuff. So I'm going to try to document this one as much as I can and let you guys follow along and see what would be involved in something like this. Okay, till we meet again.